Okay, first we're gonna go behind the deck box, and where it says C cable right there, we're gonna unplug this. And the reason we do that is in case somebody bumps this red button here, they don't accidentally put 250 volts on the cable that we are actively cutting. Okay, so this is disconnected, so there's no way that turning this on will shock us. Okay, so take the old termination, find the part that's just electrical, and cut it off like so, so that you're left with just the pigtails of the mecha connectors here. And everything else was just the stuff that had armor on it. Alright, so now we're going to cut it. You can use a Dremel, but this is going to be quicker. And just be sure to tape it before you cut it. Alright, and we just got this little cutter on a Dremel here, and we're just going to run around it and nick the outside, and then we're going to unwind the outer wires and then break them off, and I'll show you how that's done. Probably good. Okay, and once you've nicked it all the way around, then we'll take the end of the cable here and we'll start untwisting stuff. All right, and so we'll just pop some of these loose, and we'll take off about 5 at a time, just like that. And we'll break it right at the nick here, just by going like this. Nick said nick. So you take a strand of the 322 and you make it into an E shape, and you pull it and you see if it stays intact. So what would be a failure? What would a failure look like? That's what a failure would look like. It would break. It would break. Be too brittle and it'd snap. It would break, so. And that correlates with how rusty or old the wire is, right?
How brittle the wire is.
Yep. Okay.
You could test both the inners and outers and determine what percentage of the wires break in an E-King test, which would determine the viability of the wire.
Yep. Period. And if a lot of them break, we just cut back into cleaner, less rusty wire. Okay, so now we have all the outer wires cut back to here, all the outer armor cut back to here, and we have all of this inner wire still left. Before we start cutting any of the inner wire, I find that it's helpful to just take 2 of the strands that we're going to use as the ground conductor for the CTD termination, and I'll peel 2 of them back and just tape them out of the way so that I'm not confused and accidentally cut it and then have to start all over. So I'll show you what I mean there. Okay, so once you get it about here, what I usually do is just tape it out of the way so I'm not tempted to cut it when I'm cutting the rest of the stuff. And here is where we're going to make the next nick. So I'll put some tape around there. And I'll start, I'll do the little Dremel around there too. Ready? So this has all been scored now, right around here. And so I'll just peel it back and snap it off here, keeping this one intact. Once you get to the last of the inner armor here, you'll notice that the tape is in here. And the tape, we want to keep the tape because it has the markings that indicate how much cable is left on the drum. So we'll want to input that into the wire log and the wire pool database. Both of those things. There's a paper wire log and there's the digital wire pool database. See Jesus for access to that. Okay, so now we got the outer armor that stops here, and then this is just inner armor here, and that stops here. And then this is the insulation for the conductors, and this is the tape. We're gonna pull the tape off, and we're gonna read it right here, and you probably can't see it, but it says, actually can, but it's backwards, so I'll put it this way. It says 9525. 9525. So that's how many meters there are to the other end on the slip ring. But keep in mind the other end on the slip ring could have been cut back too, so that might say 20. And so you'll have to subtract 9525 minus 20 in order to get the length of the actual wire on the drum. And so now we got this back here. We're done with this tape job. We can woo sorry about that. And so now we can twist this back to where it was, and these will be our 2 ground conductors right here. Okay, just because these are sharp points here, I'm just gonna get this nice and straight and make it a little rigid so that, number one, it doesn't cut anybody who's touching it, and number 2, it kind of keeps its shape so that it's not gonna bend in and cut the insulation with the sharp edges there. You can also touch it up with the Dremel if you feel confident, but I think this usually works too. Okay, so here's the end with the conductors, and what I'm going to do is I'm just going to use this knife and I'm going to score it like this, and I'm going to score it around here. And the idea is I can then take a pliers here and a pliers on the other side and just peel it apart and expose the inner 3 conductors, the red, white, and green. Okay, so I screwed up here, and when I scored it too much, and you can actually see a little bit of conductor showing, and we don't want that because this is going to be part of the watertight area. It's too far from the end. We're going to need this part to be watertight, so I'm going to cut this off, and I'm going to start back here. Okay, so I scored it along this edge, I scored it along this edge, and I scored it around here. The goal is to take the black insulation off here and expose the inner wires. So I'm gonna start by just cutting the wire in half to and put the blades of the cutters here on both of my score jobs so that I can start to peel it back. And the outer insulation is harder than the inner insulation, so it's very easy to cut through the outer insulation and then cut the inner insulation. So there we go. Now I'm going to grab both black ends and pull them apart. I'm going to get some tweezers. It's not very symmetrical, but I'm going to grab on either side and I'm just going to roll back. And hope that it doesn't break in a weird way. Keep rolling it back. And it should keep cutting along the score line. And the whole idea here is that you're not putting anything sharp up against the inner conductors. And at the end, this is what you should have. This is how much you should expose. And all right, so here we got the Splice Scotch Cast 82F1. We want the black to be in the hole here, and we want the termination, the splice, to be in the middle. So we'll leave a little bit of space for the actual connection. So we're gonna take off the insulation there, and but we want it to look like that going in there, and we want everything to be centered. And we'll wrap this around there too. This is just out of the way for now because we're dealing with these wires. So now we'll strip these wires. Okay, and I'm gonna stagger this one a little further back, and I'm gonna stagger this one a little further back. So first I will strip off some of the black, like that, and the black conductor. And I'm just going to see how much, just going to see how far I need to cut back. Because I want, actually this is too small. I'm gonna get that one. So when it's time to make the connection, it's going to be about that far in. And we're going to make a hook with the end here, and I'll show you what that looks like. So in order to make a proper hook, I might need to cut off a little more. So I'm going to do that. Twisting the strands because it's a multi-stranded wire, and eventually when I'm ready, I'm going to make a hook here. And then I'm going to hook the other side from the mecha connector into that, pinch it all, twist it all together so it's nice and smooth, and then I'm going to slide this on like this. So right now I'm just showing you that when I put it in there, the metal part is going to be where the solder is, and there's going to be insulation where the glue is right here, and that's so the metal part, the exposed conductor, is going to be where the solder is, and there's going to be insulation where the adhesive is, and that should make it electrically as conductive as possible and mechanically as strong as possible. Now that I know how long of a conductor I need to expose here, I'm going to stagger these And so to do that, I'll just cut that off right there so that there's no way that these two can short to each other. So in the end, they're going to look like this, and it's staggered so that they can't short to each other. Okay, so this is the old splice, and we follow this. These are the old mecha connectors that we would plug into the CTD, and we were also running MISO on this cruise. So we want to keep these plugs. So we're just going to go back up to the splice here, and we're just going to cut this right here. And I'm going to peel this out of here. So this is good to keep on, just because there's so many of these, and they're like angel hair pasta, so they're very fragile. So a little bit of chafe guarding doesn't hurt. But then I'm going to take it all out here so that we can be definitively sure which one of these wires goes to which one of these. We don't want to get that screwed up. Alright, so these are all the mecha connectors. They are taped based on the conductors that they correspond to inside of the 322 wire. So for example, this one is taped with black, and it's labeled positive for the CTD. So we're going to take this one out, and we're going to strip this end, and we're going to get this ready to put in to connect to that conductor right there. And notice there's a another layer of insulation in there. Okay, so I'm going to cut off a little more of that outer insulation on the mecha connector. And okay, and okay. Notice that this does not really fit on the black insulation. Once it shrinks down, it'll get tight with the clear insulation. So that's about as far as we want to go. Now I will take off some of the white insulation here. Okay. And since I want to make a hook with this, I'm going to take off a little more. That's good. So it'll look like that. All right, so we're going to put on the heat shrink first. This heat shrink I'm going to put on the outside of this. You don't have to do this, but in my experience, sometimes the solder will drip out of this. If you heat this too much, the solder will drip out, and that's a potential short there. So I'll just put this over top of it, but for now, I'll just slide that on there so it's out of the way. And then I'll put that on like so, and it should nest inside there. So you got two heat shrinks ready to go, and now I'm just gonna make a hook out of this, and then we'll slide the heat shrinks on and shrink them up. Okay, and if you zoom in, you'll see hit 3. There you go. So now you'll see that they are hooked together, and watch as I slide this over. So now I'm just going to slide this over top so that the solder is right over top, like so. And I will Okay, now that it is cooled down, I'm going to slide the outer heat shrink just to add a layer of insulation, and we'll shrink that down too. There we go. And this is what it looks like when it's done. All right, and it should have a fair bit of mechanical strength to it. If it doesn't pass a slight pull test, then I would cut it all and start over. And we'll just rinse and repeat for the other two, and I'll show you what it looks like when it's done. Yep. All right, and for the armor conductor, it'll have some grease on it, and it might have a little corrosion. So just take some sandpaper or emery cloth and brighten it up a little bit. We're going to do the same thing with the armor, and I'm just doing it to one of the armor strands. We'll leave the other one as a backup in case this one breaks for some reason. Okay, so we got all of the conductors spliced here, and we put a little piece of heat shrink over top of the heat shrink connectors that we used with the solder in it. That additional layer of heat shrink is there just because if you overheat these at all, the solder drips out, and that's a potential short. So this is just an added insulation. You could use vulcanizing tape too. And just to show you, you could also use a butt splice as well here. Notice that we did not put any vulcanizing tape or heat shrink over this because that would make a bubble. The insulation of this wire goes inside of the cover here, and it does over here as well. So when the potting material gets poured in, it'll fill in those holes. All these are strong enough for a little pull test. I visually confirmed that they were all making an electrical connection and that there were no big bubbles inside. And so now we're gonna make it all nice and neat and stick it inside the splice, and that's what you'll see next. All right, so here we got the splice kit, Scotch Cast 82F1. You can stop it. Okay, so the mold is going to fit in there, so I'm going to make a little slot for it. Good. We're going to take some of this, and we're going to rough this up. And we're going to rough this up. All the surfaces where the potting material is going to stick to.
Okay.
All right, and the part that's going to be inside, I'm just going to put a little piece of tape on in order to keep everything together. Now we're also going to, the mold should fill in around this, and we're going to keep it tight as best we can, but this will keep it from spreading out like this on the inside when we pour the mold. And now I'm going to put this in here. Making sure that it's all in the middle there. And then we'll fill this gap with by putting vulcanizing tape around there. So with the vulcanizing tape, that should keep any of the potting fluid from coming out. All right, so this is what it's going to look like when we pour the mold in. All of the wires should be pulled tight inside so they're right in the middle, and all of this should be neatly sealed off. And we'll line off that little part. Okay, that's all right. And should be good. Okay, and I just taped it because I want to make sure that it's not wiggling around. And now should be. Okay, now we're ready to mix the mold. It's pretty difficult to pull it apart. You'll feel like you're gonna break it and it's gonna burst out everywhere. And find a real strong guy, if there's one around, to do this. Okay. So I pulled it apart in the middle here, and now I'm just gonna mix it all together until it's a uniform color for no longer than a couple minutes, because then it will start to set. Oops. Here is the final result. And then you find the cable that adapts the 2-pin MCIL wet mateable connector to mecha. It's labeled plus and ground. Make sure to keep the dummies. Make sure to plug in yellow to yellow, the ones that indicate hot and for CTD, and green to green, the ones that indicate negative for CTD. And then you take the other end of this cable and plug it into JT1 on the Seabird 9. And now this is the terminated end of the 322 cable. The unused conductors, make sure you have dummy plugs on them and that they're watertight. And now we'll go look in the junction box to make sure that the proper conductors are connected down there. Okay, so I'll walk you through the whole thing. Here's the 322 cable. This is the end. This is just the inner armor. And then here, it's just the 2 ground conductors there and the 3 main conductors inside. And then there's about 4 feet of that. And then we have our splice that we just made. And that connects the one of the ground conductors to the green mecha connector. It connects the red conductor inside of here to the one taped red here. And the white to the one taped white here, and the black to the one taped black here. So I'll show you where that tape is. So here are the red and the white, which are currently not being used, but they can be hot swapped as long as you check all the junction boxes and make sure that everything is wired correctly. And then there's the green and the black here. So this connects to the armor, and this connects to the black conductor, which we tested as best. And it's taped yellow on both sides as well, because that is currently what we're using as the hot one. If you wanted to use this as your hot, then you would just take the yellow tape off here and indicate that this is the hot one here, so that it is clear which one to connect to the hot here. And then now this is the cable that adapts to what plugs into the Seabird 9, and it's a MCIL 2-pin connector, and it plugs into JT1 on the Seabird 9. And then you can also put some of this cable loom on here, the split loom, to keep all of the mecha cables together and give them a little bit of protection, because it can be unwieldy to deal with all these loose cables here. It turns into a pile of spaghetti pretty quick. So then we're going to plug it in. And when you're plugging it in to put it in the water, it's good to clean it with some alcohol, spray it with some compressed air, then putting a little tiny thin film of Dow Corning Electrical 11 grease. All right, so in the main lab here is the junction box for the deck side of the 322 cable here, and inside you'll see that this is labeled CTD plus, and that's the black one. That corresponds to B on the back of the deck box, and white corresponds to A on the back of the deck box, and that is the ground. And notice how the ground connects to green here, which is also labeled CTD minus, and the green corresponds to the green taped mecha connector and the armor, or otherwise the ground of the 322. And black corresponds to, these are all the same colors as what's in the 322 and what's taped on the mecha connector. So black was our hot, and so black is connected to hot there. So that's something you should confirm before turning on the deck box. Come here and open that up and just confirm that it is the same. Because NOAA actually changed this, and other operations might change this. So this is black, again, is hot, white is negative, and white corresponds to A, and black corresponds to B. And then the A and the B are right here in the back of the deck box. You can kind of make out that the left is A and the right is B there. So if you need to pin anything out. And then we're good to plug this in and turn it on. And again, this has 250 volts coming out of it, so make sure all the connections are tight. All right, go, Vinny. Nice. There we go. So if it stays in this mode, that's bad, and that means that the mecha connectors are either disconnected or it means that there's a short or something. There's no communication to the CTD, and if that stays on, I would power off immediately and go troubleshoot the connection. 10 means that there is connection to the CTD. 11 means the pump is on. You don't want to run it on deck in 11 mode with syringes hooked up to it. But either way, 10 is good. So we have communication.